Hey everybody, welcome to Chapter 7, Section 3, Part 1, Intro to Logarithms. In this video I'm just going to go over what a logarithm is and how to convert from logarithmic form to exponential form and vice versa, exponential form to logarithmic form, and then we'll do a couple of solving logarithmic equation examples too. So a logarithm is kind of a funny sounding word. But in short, it's the inverse of an exponential equation, okay? So a logarithm is defined by this right here. So you have log, and this little b is called your base. So log base b of y equals x if and only if b to the power of x equals y. So in other words, if I zoom in here, you can take the base, raise it to the power of what it equals, and then that is what the exponential form will equal. So it's saying b to the power of x equals y right there. That's kind of the definition of that. It's important to know that b and y be positive real numbers with b not equaling base 1. B is not a base of 1. And then it says the logarithm of y with base b is denoted by log by and is defined as, oh, I covered that. Okay, so that still might sound confusing because we just only have letters here. So I put an example here. You read it as log base 3 of 81 equals 4. So if you use that kind of pattern I showed you, you take the base, raise it to the power of what it equals, what the log equals, and then then it'll, I don't know, the product of that or whatever equals 81. So it's saying 3 to the fourth power equals 81. See, 3 to the fourth power equals 81. So I put some bullet notes here. I kind of already covered this one. The expression log base b of y is read log base b of y. The base number will always be positive, so you'll never see something like log base of -2. And then if there's no base number written, then it's assumed a base 10. So if you just see log 5, it means log base 10 of 5. And then anytime you see ln x, that's called the natural log. I don't know why. I think it's written ln just to keep the L first, like for log. But just think NL, natural log, but it says log natural. And it means log base E of x. So yeah, that's what the natural log is, and I'll go over more of that in the other videos in this chapter. That being said, let's do these examples. We're going to rewrite these logarithmic equations into exponential equations. So we have log base 2 of 16 equals 4. So I have a base of 2. I'm going to raise that to the power of 4, and then that's going to equal 16. So I just write 2 to the power of 4 equals 16. That's all I want you to write down. So for letter B, I have e to the power of 0 equals 1. E to the power of 0 equals 1. Anything to the power of 0 is 1, if you think about it. Okay, so for letter C, I have log base 12 of 12 equals 1. Why does it say that? Think about it. 12 to the first power. What do you think that's going to equal? That's going to equal 12. Letter D, I have log base of 1/4. So you can have fractions, you just can't have negative numbers for your base. So this says 1/4 to the power of -1, so I'll put that in parentheses, equals 4. Why is that so? If you think about it, what do negative, oh, I didn't draw the arrow over there. What do negative exponents mean? Negative exponents make fractions. So if you think about it, 1/4 is already a fraction, so if you have a negative exponent with the fraction, you can just flip it. So instead of saying 1/4 to the power of -1, I can flip it. 4 over 1 to the power of 1 also equals 4. Just, the more you know kind of thing. But I guess ultimately this is what I'm looking for because that is the literal translation of what I gave you before in part D. So I hope that makes sense. So in this section here, we're going to rewrite exponential equations, meaning we're going to convert them from an exponential equation into a logarithmic equation. So you know how I had the pattern of like I circled that first number and then basically I skipped the second number and I pointed to the one that equals over here, and then I took that and pointed that one over there. It still kind of works if you think about it, because it's going to go log, and then the first number you write is the base, and then the next number you write is going to be big, and that's going to be 125, and then that will equal 3. So you can kind of always check logs. Your calculator can do logs. It's got a log button where it's log base of 10, and then it's also got a log button where you can change the base. So if you ever typed into a calculator log base 5 of 125 and then you press enter, it'd tell you the answer is 3. Just FYI. But yeah, that's the answer to part A, okay? So part B, I'll do that same pattern I did before. And so I have log base 10 of 0.1 equals -1. That's all I'm looking for. You might also see it written as, since I put it earlier in the notes, that whenever there's a base 10, you don't really see the base number written. I guess it's the default base if you want to think about it like that. So you could see it written as log and then just a big 0.1 next to it equals -1. So yeah, either one of those is fine for part B. For part C, I'll start with 8. I'll draw my arrow to 4, and then I'll take 4 and draw my arrow to 2/3, meaning log base 8 of 4 equals 2/3. And that's that. Okay? So that's all there is to it when you're converting from logarithmic to exponential or exponential to logarithmic. Okay? So here I have these. These are evaluating logarithms, some basic solving, if you want to think about it like this. So when I solve them, I like to convert them to exponentials. Sometimes it's easier to think about it like that. Sometimes you can just type it in the calculator. I'll point that out when that happens. But here I have log base 5 of x equals -1. So if I were to convert this, it says 5 to the -1 power equals x. Well, we can figure out 5 to the -1 power. You can type that into your calculator, or just think, what do negative exponents mean? They mean fractions. 5 to the power of -1 means 1 over 5 to the power of +1 now. But you don't really have to write power of +1 ever. That's why I wrote it in red. But anyway, that's going to equal x, so we just figured out our answer. All you had to do was figure out what 5 to the power of -1 is, and that's 1/5. So yeah, that's all part A is. Something like part B is something you could actually type into the calculator. Change your base to 4, type in log base 4 64, press enter, and it'll give you the answer. But if I ask you to show your work by like converting it to exponential form, then you're going to do this. You're going to write 4 to the power of x equals 64. And so you can plug and match or plug and play 4 to this power, just keep pressing enter. Or you can pull up a table. You can type in 4 to the power of x into your graph, and pressing Control T, right, and pulling up the table. And so you'll see with each, as it grows, those are your exponents. 4 to the 0 power is 1, 4 to the first power is 4, 4 to the second power is 16, 4 to the third power is 64, and there we found our answer. So we just write x equals 3. And that's it. So, a couple different ways you can approach this one. For part C, I have x as my base. So I'm going to rewrite x to the third power equals 216. So, you can try and solve this in your head. Just plug in numbers, raise those to the third power, and, just keep trying it until you hit 216. Pull up a table, x to the third power, press Control T, scroll until you see 216 in the y column. Or you can solve it by what's the opposite of the third power, the third root. So what's the third root of 216? That's actually going to be 6. And it's not a plus or minus. You only put plus or minus for even roots. 3 is an odd root. So I just write x equals 6. and that's the answer. So this last example here, if it's equaling x, that's something you can type into the calculator again, just something I want to point out. But let's convert it just for the sake of doing so. So we have 36 raised to the power of x equals 6. So if you're ever stuck, you can always plug this part in, plug it into a graph, pull up the table, scroll until you find 6 in that y column, then you found, just look at whatever the x number is, you found your answer. That's really kind of the easiest way of going about it if you can't figure it out in your head. Me, I like to do it in my head. So how do I go from 36 to 6 with an exponent? I mean, like, you don't exponents make numbers get bigger? Yes and no. If it's a whole number exponent, or if it's bigger than 1, I should say, it'll get bigger. If that exponent's smaller than 1, it'll get smaller. So how are 36 and 6 related? I know that the square root of 36 is 6. So I'm just going to write this right here. Square root of 36 equals 6. Sorry for the background noise. I live by a busy street. Anyway, so if the square root of 36 equals 6, how do I denote that as an exponent? What do I write for the value of 6? Well, if you'll recall, the square root, if you were to write that as an exponent, that'd be the power of 1/2. So all I'm trying to say is x equals 1 over 2. All right? That's the final answer. So I could write the square root of 36 equals 6, or I could write 36 to the 1/2 power equals 6. Okay? So yeah, thank you for watching this video. I hope it helped. Stay tuned for additional parts. Goodbye.